Hello, in this video, we will introduce hash functions and hash code. A typical hash function first converts a search key to an integer value called a hash code. Then compress the hash code into an index to the hash table. In C++11, you can use the hash code with a key type and with the key value here to return an unsigned integer hash code for an element of a primitive type or an object type depending on the type and the value of the element. For example, let's look at this code right here. You can get the hash code for the string ABC using this hash with the key type string. And this is the same hash with the key type string and with the strings ABC. This is the int type, this is short type, this is the float type. Now, this is the sample run. So this is the result from this. So please note that if the values are the same with this in the same type, so this is ABC, ABC, so this is the hash code. The hash codes are the same. So the hash function returns the same hash code if the two elements are the same using the same type. During the execution of the program, invoking this function, this is this one here function to get the hash code, multiple times returns the same integer, provided that the object's data are not changed. Two unequal objects may have the same hash code, but the function in C++11 is to avoid too many such cases. Compressing hash code. The hash code for a key can be a large integer that is out of the range for the hash table index. So you need to scale down to fit in the index range. Assume the index for a hash table is between 0 and n-1. The most common way to scale an integer to between 0 and n-1 is to use remainder. So this is the hash code to remainder n, to compress it to fit to the table size. Ideally, you should choose a prime number for n to ensure that the indices are split evenly. However, it's time-consuming to find a large prime number. We will choose n to be a value of a power of 2. This is a good choice. When n is a value of the power of 2, this hash code remainder n is same as hash code using the bitwise AND, n-1. So it will give you the same result, but this using the bitwise AND is much, much more efficient than using the remainder operator. Another thing to note that very often we use a supplemental hash function. So like this, in addition to the primary hash function, we do it twice. The supplemental function may be defined something like this. So this is using the bitwise operators. So doing the right shift and doing the exclusive OR. So this is just to ensure that you get that this index is evenly distributed. that is all for this video on hash function and hash code. See you on the next video.